I've been carrying a sentence around all week like a stone in my shoe, and I need you to either pull it out or admit it's true. Here it is. The iron in my blood, the real iron, the stuff that makes it red, that carries the breath from my lungs out to my fingertips, did not come from the earth. It was forged inside a star, one that lived and died in fire, before the sun was even a cold cloud of gas. And so was every other heavy atom in me, cooked light years away and flung across the dark, so that ages later some of it could stand in this room and be me. So which is it? The most beautiful thing I've ever heard, or the most elaborate lie you've let someone tell me?
It's true, every word of it. And I'm not going to let you believe it just because it's beautiful, because that's the worst reason to believe anything. So put the stone back in your shoe for a while. We're going to earn it.
Earn it. All right, though I'll note you didn't even pause before you said it's true. No throat clearing, no, well, roughly. That's either total confidence or a very good bluff. And I've watched you long enough to know you save the flat, instant answers for the things you can actually prove. So prove it. Start wherever you like, but I want to be able to check every step, or it doesn't count.
Total confidence, but the kind you can check, which is the only kind worth having. Cast your mind back to where we left off last time. We just built the whole cosmic web. The dark scaffolding, the gas falling in along it, the very first stars flickering on down the length of the filaments.
I remember all of it. Galaxies strung out like dew on a spider web, the dark scaffolding underneath, the gas pooling into the bright knots, the whole thing lighting up along the threads. That's an image I'm going to be dining out on for years. But I notice you're steering me back to the gas, specifically, and you've got that look. The one that means I've walked straight past something obvious, and I'm about to feel silly for it.
Keep it, it's a good one. But here's the thing we hurried straight past on our way out the door, and it's the hinge the whole night swings on. Those first stars switched on out of raw gas, and that gas is the ingredient list for everything that comes after it. Stars, planets, oceans, you. So before anyone strikes a single match, what's actually in the pot? What did the young universe hand its first cooks to work with?
I want to say everything. The gas that goes on to make stars and planets and eventually me, surely it's got the whole shopping list already tucked into it, just waiting to be sorted out and assembled. That's how I've always half-pictured it, if I'm honest. A great cloud with a little of everything in it, and stars and worlds are just the sorting. Please tell me the horrified pause means I've got that wrong.
That's the natural guess, and it's wrong. And the exact way it's wrong is the whole story tonight. So go back further still, all the way to the fireball's first few minutes. What did we say came out of that furnace, right at the start of everything?
Oh, the lightest things. Hydrogen and helium and, you made me spell it out in words, a whisper of the next one up, and then the whole thing slammed shut. Almost nothing heavier than that.
Almost nothing heavier. Now say it again, and really hear it this time. The Big Bang, the entire roaring furnace of the newborn universe, cooked hydrogen and helium, a breath of the next lightest, and then it quit. That is the shopping list in full. That is everything the young cosmos had to work with.
Two things. Two-ish things.
Two-ish things. So picture the periodic table, that big chart on the science room wall, all those neat little boxes marching across it.
The one nobody can read from the back row.
That one. Well, the Big Bang filled in the first box and most of the second, and then it set down its pen and walked off. Every other box on the chart, the carbon, the oxygen, the nitrogen, the calcium, the iron, the gold, all of it, every last one stood empty, blank. For the whole first stretch of time, the universe simply did not contain those things.
Wait, that's Hang on, that's nearly the entire chart, nearly every box. You're telling me the young universe was missing almost everything the world around me is actually built out of. Not a few rare trimmings, the main ingredients, the stuff of rock and water and bone, all of it just not invented yet.
Almost everything you'd point at and call stuff. No carbon means not one living thing anywhere. No oxygen means no water and no air. No silicon and no iron means no rock. No planet with a hard ground under it. A universe of pure hydrogen and helium is a universe of gas and starlight, and precisely nothing you could ever stub your toe on.
So a whole galaxy of nothing but hydrogen and helium is, and you said this yourself, at the door on your way out last time, a dead thing. Blazing away maybe, plenty of light, but nothing in it could ever be alive, and nothing in it could ever be solid. A sky full of fires, and not one hearth to sit beside.
A dead thing, blazing and beautiful and utterly barren. And that is the gap we have to close before the night's out. Somewhere between that empty chart and your very full, iron-rich, oxygen-breathing self, someone went along and filled in all the missing boxes. So the question of the evening is simply, who?
And you're about to tell me it was the stars. You've got that build-up cadence going, the one where you make me guess the answer you've already got loaded. Fine, I'll play. It was the stars, though I've no earthly idea how a star, of all things, fills in a chemistry chart. It's a ball of fire. Fire doesn't make new elements, it just burns the ones you feed it.
I'm going to make you tell me. But yes. The whole rest of that chart, every single box the Big Bang left blank, got built inside stars. Stars are where the periodic table finally gets finished. That's the sentence I want you able to defend by the end of the night, not just nod along to. So let's take it apart, carefully. And we start with the very thing you just called a hot lamp.
All right, but I have to lean on that, because a star to me is just a big bright ball of gas, a hot lamp hung up in the dark. How does a lamp turn into a factory that manufactures brand new kinds of matter?
Because a star is not a lamp. A lamp burns. It takes some fuel, combines it with the air, shuffles the loose outer bits of atoms about, and gives off a bit of light for its trouble. Ordinary fire. A star does something far, far deeper than fire. A star reaches all the way down into the very hearts of atoms and welds them bodily together into new ones.
The hearts of the atoms? You mean the nuclei, the little dense knot right down at the center, the thing that actually decides whether you're looking at hydrogen or gold, or anything in between. So you're not talking about ordinary burning at all. You're talking about reaching into that knot and rearranging it. That's a completely different order of business, and I can feel it's the whole point.
The nuclei. The tiny, stubborn knots that decide what element a thing actually is. Welding those together, that's what we call fusion. And it is the very same trick the Big Bang pulled in its opening minutes, remember? The difference is only this. The Big Bang had a few short minutes before it cooled off, and the window slammed. A star has all the time in the world.
So it's the same cooking the Big Bang did in its first minutes, just slow. Low and slow, instead of the flash in the pan. The fireball had a few frantic minutes, and then the door shut on it. A star gets to stand at the stove for as long as it likes. That actually makes a kind of sense to me. Give a furnace enough time, and it can build up what the quick one never got the chance to.
Low and slow, over millions upon millions of years. That's it exactly. Now, why does a star fuse at all? What lights the furnace, and what keeps it lit for all those ages? You already know the answer to this. You just haven't caught yourself knowing it yet.
Do I? Go on then, tell me what it is I secretly already know.
Gravity. A star is an unthinkable quantity of gas and gravity is forever trying to crush all of it inward, in toward the center, into a smaller and smaller ball. And here's the piece you have in your bones already. Squeeze a gas, and it heats up. Squeeze it hard enough, and the middle gets ferociously, outrageously hot.
Hot enough to fuse. Hot enough to slam the nuclei together so hard they stick, instead of just bouncing off each other the way they'd plainly rather. Because they don't want to touch, do they? They're all crowded with the same charge, all shoving each other away. So you'd need real violence, real heat to force them close enough to weld. And gravity, just by squeezing, supplies it. That's rather beautiful. The crushing is the cooking.
Hot enough to fuse. Down in that crushed, blazing core, hydrogen nuclei come flying at each other so hard and so fast that they stick, and stick as helium. And every single time a clutch of them welds into one, a little spit of energy comes squirting out.
And that energy is the shine. That little spit of energy times some countless, unthinkable number of weldings every single second, all of it leaking up and out. That's the actual starlight. So every star I've ever looked at is doing this, right now, in its middle. It's not glowing because it happens to be hot for no reason. It's glowing because it's busy. Every star in the sky is a furnace showing its receipts.
That is the starlight, the light you see, crossing all that dark to land in your eye. It's the energy of hydrogen turning patiently into helium, deep in a core you will never lay eyes on, leaking out at the surface at last as a glow. So when you look up at a star, understand what you're really watching. You are watching fusion pay its bill.
Fusion paying its bill, that's lovely. But now I'm worried about the star, because you've got gravity crushing inward on it this whole time, relentlessly. What's stopping the poor thing from simply caving in and collapsing down to a dot?
The most elegant standoff in all of nature. Gravity squeezes inward, the furnace at the heart shoves outward. All that fusion energy hammering out against the crush, holding the walls up from the inside. In and out. Crush and push. Held in a near-perfect balance. A star lives its entire long life as a quiet truce between those two.
A truce. So the star is basically holding itself up against its own gravity, with nothing but its own fire, propping the ceiling up with the heat of the blaze in the basement. That's an extraordinary way to stay standing. It works perfectly right up until the fuel runs thin and then, well, I don't like where that's heading at all, but I can already see it heading there.
With nothing but its own fire. And you can already feel where the danger has to be, can't you? If the fire is the only thing keeping gravity out, then something is going to go badly wrong on the day the fire finally starts to run low.
Oh, that's ominous. The day it runs short of hydrogen to burn, the push-out weakens. And there's gravity, which has been leaning on the door the entire time, patient as anything, just waiting for it.
Patient as anything, and it never once got tired, and it never once looked away. Hold on to that, we'll need it before long. But the star doesn't simply surrender at the first shortage, and how it fights on is exactly where our empty chart starts filling in. Before we get there, though, one thing decides almost everything about how a star lives and dies, and it's the one thing you'd probably guess last.
Try me. What's the master switch?
Its size, how much gas it was born with. A star's weight at birth sets its whole fate, how hot its core runs, how fast it burns, how long it lives, and how it dies. And the arithmetic of it is the opposite of what people expect.
The opposite how? I'd have guessed the obvious thing. Bigger star, bigger tank of fuel, so it lasts longer. More petrol, longer drive. That's just arithmetic. You're clearly about to tell me the arithmetic lies. So, go on, tell me why the big ones don't win.
Everyone guesses that, and it's backwards. A giant star has a monstrous tank of fuel, yes, but it's so heavy that gravity crushes its core to a far fiercer heat, and it burns through that fuel in a wild, extravagant hurry. The biggest stars blaze furiously and live fast and die young, a brief, brilliant life over in a cosmic eye blink.
And the little stars?
The little stars are misers. A modest star, something like our own sun, sips its fuel so gently and so slowly that it can shine steadily for an almost absurd stretch of time. Far longer than there have even been stars, some of them will last. Small and stingy is the recipe for a long life. Big and lavish is the recipe for a short, spectacular one.
So the flashy ones burn out young, and the careful ones go the distance. There's a moral in there my grandmother would have loved.
There's a whole sermon in there. But it matters for tonight, and here's why. It's the giants, the ones that live fast and die young, that do most of the heavy cooking, and then die dramatically enough to hand the results back out. They don't keep the world waiting. Now, back to the ladder. When the hydrogen in the core finally runs low, and the fusion falters, and the push-out weakens, what did we say gravity does?
It squeezes again, harder this time, because the fire that was holding it off has weakened. And squeezing means heating. You drummed that into me. So the core gets even hotter than the hydrogen-burning heat it was already running at, which I assume is the whole trick. Gravity itself keeps turning up the temperature, one notch at a time, every time the star runs short of the last fuel.
Hotter than ever before. And at that new, fiercer temperature, something new can catch light. The helium, the ash, remember, the spent left over from burning all that hydrogen. The helium itself starts to fuse.
The ash becomes the fuel.
The ash becomes the fuel. I love that you put it that way, because that phrase is the heartbeat of the whole process. Helium fuses, and what do you suppose you get? Welding helium nuclei together. Something heavier still. You begin to make carbon. You begin to make oxygen.
Carbon. Oxygen. Now wait, those aren't exotic, faraway names to me. Those are me. That's the stuff every living thing is built out of. The stuff in the air I'm breathing at you this very second. The stuff in the wood of this table. And you're telling me there was simply no way to make any of it until a star had lived long enough to burn down to its ashes, and then start in on the ashes. None of it came free with the universe.
The stuff of every living thing, and the air in your lungs. And not one atom of it existed anywhere in creation until a star had burned its hydrogen down to helium and then squeezed that helium hot enough to fuse it. The carbon in every single cell of your body was assembled, one nucleus at a time, in the heart of a star.
I need a second with that one. Every pencil, every diamond, every leaf, every living creature that's ever drawn breath, all of it carbon. And there was a whole long era when the universe simply had none, not a speck. I keep wanting to file carbon under obviously always been around, like air, like water. And you keep yanking the rug. No, it had to be built by something at a particular time. Nothing was just lying about waiting to be used.
Not a speck. The box on the chart stood empty. A star filled it in, and a big enough star does not stop there, because the same trick just repeats. The carbon and oxygen pile up as a new sort of ash down in the center. The fusion falters. Gravity squeezes, the core runs hotter yet, and now even the carbon and the oxygen catch and fuse and become something heavier again.
So it really is a ladder, each rung hotter than the one beneath it, and each new rung builds a heavier element out of the ashes of the last. And you climb it by squeezing harder and harder. Every step up costs you a fiercer core. That's a strange sort of ladder, where the climbing gets more expensive the higher you go, not easier. I'd expect a thing like that to run out of climb at some point.
A ladder. That is the perfect word for it. climbing the periodic table one rung at a time and paying the toll for each new rung by crushing the core a little hotter than the last. Hydrogen to helium, helium to carbon and oxygen, and on up it goes, heavier and heavier, step by patient step.
And I'm going to guess that not every star gets to climb the whole ladder. You made a point just now of small versus big.
Now you're thinking like an astronomer. No, they don't all climb it, and this is where a star's birth weight comes back to rule everything. A modest star, our gentle sun, simply hasn't the heft to crush its core to the truly savage temperatures the upper rungs demand. It'll manage hydrogen to helium and later helium to carbon and oxygen, and then it's done. It has run out of squeeze. The ladder ends there for a star like ours.
Whereas a giant,
many times the sun's weight, can crush its core to heats a little star could never dream of. So it goes on climbing, rung after rung after rung, building heavier and heavier elements down toward its center, long past where the sun would have stopped cold.
So, inside one of these giants, near the very end of its life, what have you actually got in there? I'm trying to picture it. If the deeper you go, the hotter it gets, and each temperature cooks its own element, then it can't all be mixed together in a jumble, can it? There'd have to be a kind of order to it. Different elements sitting at different depths, like layers.
Picture an onion. That is the honest picture, and it's a gorgeous one. A giant star in its final days is layered exactly like an onion. Hydrogen still burning quietly in a thin skin near the surface, and beneath that a shell of helium burning, and beneath that a shell of carbon, and deeper, heavier shells below that, each one hotter than the last, each one cooking its own element all the way down.
An onion made of fire, with every single layer busy cooking a different piece of the periodic table. That's another one I'm going to have real trouble sleeping on.
Lose the sleep gladly, because we've nearly reached the center of that onion, and the center is where the entire story pivots. But before it pivots, I don't want you thinking every star ends in drama. Most don't. Let's give the gentle ones their due first. What happens to a modest star, our sun's sort, when it finishes its climb and the fire finally gives out?
You tell me. I've spent the last stretch bracing for something violent. Collapse, explosion, the works. So go ahead and surprise me by making it soft. Though I'll admit I can't quite picture a gentle way for a star to die. When something that enormous stops working, I'd expect it to fail loudly.
It's soft. A star like the sun, near its end, swells up enormous, bloats out into a vast, cool, ruddy giant, so swollen it would swallow its innermost planets whole. And then gently, almost tenderly, it lets its outer layers go, puffs them off into space as a great glowing shell of gas, drifting slowly outward. No bang, just a long, luminous exhale.
A luminous exhale. That's a lovely phrase for a death, and not at all the ending I was braced for. And what's left behind when it's finished breathing out all those layers? There must be something. You don't just breathe your whole self away into the dark. What sits there in the middle once the fire's finally gone out for good?
A small, dense, fading ember at the middle, the burnt-down core, no longer fusing anything, just sitting there glowing from its own leftover heat and cooling, ever so slowly, over ages and ages. But mark what that gentle death did on its way out. Those puffed-off layers weren't empty. They carried the carbon and the oxygen that star had cooked, sighed out softly into space for the next generation to use.
So even the quiet death still seeds the gas, still hands its harvest on. It just does it kindly instead of catastrophically.
Kindly and slowly, and without a sound. That's how a great many of the lighter of your heavy elements got out into the universe. Not blown out in a blast, but breathed out by dying stars too small to explode. Hold that beside the giant, though. because the giant does not get to go gently.
Right, back to the center of the onion then, and back to the giants, the ones that don't get the gentle exit. We'd climbed the ladder all the way up, shell after shell, hotter and heavier, and you said it reaches a rung it just can't get past. Which has been nagging at me the whole time, because a ladder that suddenly stops needs a reason to stop. So what's the rung, and why that one of all of them?
It reaches a rung it cannot pass. There is one element where the whole building project simply stops dead, and no amount of heat or squeezing will carry it one step further by this steady burning. And that element, you already know its name, because it's the one that started our whole night.
Iron, the stuff in my blood.
Iron. The giant climbs and climbs, forging heavier and heavier nuclei toward its heart, and it climbs right up to iron, and at iron it slams into a wall it cannot get over. Not a wall it struggles with, a wall it cannot pass by patient fusion, however hot it gets, however hard gravity leans. Iron is the very top of the ladder.
But why? What is so particular about iron, of all the things on that chart? Why does the ladder just end there, at that one rung and not another?
This is the deepest little fact in all of tonight, so let me set it down slowly and carefully. Every rung up the ladder so far, every fusion, has paid out energy. Remember, that spit of released energy is the entire point of the exercise. It's what pushes back on gravity and keeps the star's truce alive. Weld light nuclei together, energy comes out. That has been the deal the whole way up.
Right, fusion pays the star. Every weld throws off that little spit of energy, and that energy is the star's whole income. It's what buys the outward push that keeps gravity at bay. So the star isn't really burning to make light, is it? The light's almost a side effect. It's burning to stay standing up. The fire is the rent.
That's the business model exactly. And iron is precisely where the business model collapses. Iron is the most tightly bound, most thoroughly settled, most contented nucleus there is. The very bottom of the well, the most stable arrangement matter can possibly fall into. And to build anything heavier than iron by welding, you no longer get any energy out at all. You have to put energy in.
Oh, so fusing past iron doesn't pay the star anymore, it charges the star. It's a losing trade, the first one the furnace has ever been handed. Every step up until now paid it a profit. This one would put it in the red. And a star that's been running on profit its whole life can't afford one single trade that costs more than it brings in. So it just doesn't make it.
A losing trade. Fusing iron up into something heavier drains energy instead of releasing it. So the giant, which has run its entire life on the profit from fusion, climbs to iron and finds the profit is simply gone. It can make iron, but iron will not burn to pay the next bill. It is quite literally the ash that will not catch.
The ash that will not catch. So the fire stops. There's just nothing left in there that will pay out. The star's spent its whole life climbing this ladder rung by rung, always with a fresh fuel waiting the moment the last one ran dry. And now it climbs to iron and finds the shelf bare. No next rung, no next payment. Just a heart of iron that flatly refuses to burn.
The fire stops. And now cash in the thought I told you to hold at the very start. What was the only thing keeping this enormous star from caving in?
The fire, the push out, and you've just told me the fire stops, which means, oh no, gravity. Gravity that's been leaning on the door this whole time, waiting.
Gravity? That's been leaning on the door this whole time. And the instant that iron core can no longer pay the outward push, the truce is finished, and it is finished in far less than a heartbeat. There is nothing at all left to hold the walls up, and the entire crushing weight of a giant star falls in on that iron heart all at once.
All at once? How fast is all at once, really?
faster than you can picture. The core caves in a fraction of a single second, a heart of iron broader than a world, crushed down to a ball you could throw a blanket over, in less time than it takes to blink. And then it rebounds. And when a star that size falls in on itself and slams back out, it detonates. The whole outer body is blown clean apart in a blast so violent it can, for a few days, outshine every other star in its galaxy put together.
One dying star, outshining 100 billion others. From running out of fuel, that is, hands down, the most spectacular way to go bankrupt I have ever heard of.
Bankruptcy as fireworks. And here, right here, is where your two loose threads finally get knotted together. So watch closely, because two enormous things happen inside that single explosion.
Two things. Go on, give me both.
The first thing. Remember the onion, all those layers, all those elements the star spent its whole life so patiently cooking. The carbon, the oxygen, the silicon, the iron, hoarded up inside it. The explosion seizes that entire harvest and flings it out into space. Every scrap of it, scattered across light years in a single heartbeat's blast.
So the star spends millions of years quietly making all of it, and then, at the very last instant, throws the whole pantry straight out the window.
Throws the whole pantry to the winds. It doesn't clutch its treasure, it gives it all away. Every element it ever built seeded out into the gas around it. That's the first thing. Now the second thing, and this is the one you've been circling since your very first sentence.
The gold. You've been dangling gold in front of me since minute one, and I have not once forgotten it.
The gold. Now, everything I've told you so far, the whole ladder, stops dead at iron. Say it back to me, because I need you to hold this exactly right. Steady, patient core fusion cannot make gold.
It can't make gold, because gold sits past iron on the chart, and past iron every rung is a losing trade. You'd have to spend energy to build it instead of getting energy back. So the quiet furnace simply won't climb there. It can't afford the fare. Which leaves me genuinely stuck, because gold plainly exists, I've held it, so it had to come from somewhere.
Precisely. The calm furnace cannot make gold, or silver, or platinum, or the uranium buried in the ground. None of the heavy, rare, precious things that live past iron on the chart. So where then? If the patient furnace is barred from it, where does the gold come from?
I honestly don't know. You've just closed the only door I had. If the star's core can't build it, and the Big Bang didn't build it, then where?
Not from the furnace living, from the furnace dying. In the unimaginable fury of that explosion, the heat, the flood of particles, the sheer violence of a giant tearing itself to pieces, conditions get so far beyond anything a peaceful core ever knew that nuclei are jammed together even past the iron wall. The energy that quiet fusion flatly refused to pay, the explosion pays by sheer brute force, in an instant.
So the heavy stuff, the gold, the silver, all of it, isn't made by the star living its life at all. It's made by the star dying its death. The one moment I'd have written off as pure destruction, pure ending, is actually the only moment creative enough to make the most precious things there are. That's completely backwards from how I'd have guessed it, and I think that's exactly why I like it.
It's made by the star dying its death. That is the single line I most want you to carry out of this room tonight. The lighter of your heavy elements were cooked in the long, patient life of a star. But the heaviest, rarest ones, those are forged only in the extreme violence of stellar death. And the very heaviest may need something wilder still, the burnt-out, unthinkably dense cinders that dead stars leave behind when two of them find each other and collide.
The collision of the dead. You do say the loveliest things in the most alarming possible way. The collision of the dead belongs carved on a headstone, so let me get properly morbid about it then. A gold wedding ring, the thing people slide onto each other's hands as a promise, that came out of a star's death throes. That's what's glinting away on all those fingers.
Out of the death throes of one, or the collision of two burnt-out husks of them, long ago and far away. That ring is a little frozen splinter of a cosmic catastrophe, and you wear it on your finger to the shops. Every scrap of gold that has ever gleamed in all of human history was forged in a violence neither of us could survive, being within a whole galaxy of.
I am never going to look at a jewelry shop window the same way again. It's not a shop, it's a museum of ancient disasters, tastefully lit.
A museum of ancient, faraway disasters, arranged very prettily under glass. But now, let's chase the harvest, because scattering all of it into space is not the end of the story. It's the beginning of the part that ends up being you.
This is the recycling bit, isn't it? I can feel a recycling bit approaching. You've got the wind-up. So the star's flung all its lovingly made elements out into the dark, gentle or violent, and now that stuff has to go somewhere and do something, or it's just litter drifting about. Where does it actually go?
The recycling bit. So, that dying star, gentle or violent, has handed its harvest out into the surrounding gas. And what was that gas beforehand? Very nearly pure hydrogen and helium. The dead, barren thing. Only now it has been salted, enriched, seasoned through with carbon and oxygen and iron, and a fine dusting of the precious heavy stuff.
So the empty pot just got a delivery of ingredients. The barren gas, the dead thing, all hydrogen and helium, somebody finally came along and stocked its pantry. And I'm guessing this is where it all starts to snowball, because now that gas can do something it never could before. It isn't just fuel anymore, it's fuel with the makings of worlds mixed right into it.
Somebody finally stocked the pantry. And that enriched gas drifts and swirls and gathers, and eventually a patch of it grows dense enough that gravity, always gravity, takes hold and collapses it, and it lights up as a brand new star. A second-generation star, born not from pristine gas, but from gas already seasoned by the death of one before it.
So the new star is built, quite literally, out of the ashes of older stars that died before it. I want to make sure I've got the full weight of it. It's not that the new star is like the old ones or descended from them in some loose, poetic way. It's made of the actual atoms the old ones forged and threw off. The dead stars are physically inside the new one.
Out of the ashes. And here comes the payoff. This new star forms with a whirling disk of that same enriched gas and dust, wheeling around it. And now that the gas carries heavy elements, now that the dust has real carbon and silicon and iron in it, those specks can clump, can stick to one another, can gather into grains, and grains into pebbles, and pebbles into rocks, and rocks into whole worlds.
Planets. You need the dead stars to have gone first, or there's simply nothing solid lying around to build a planet out of in the first place.
You need the dead stars to have gone first. A first-generation star, born of nothing but hydrogen and helium, has not one solid thing to make a planet from. No rock, no metal, no ground of any kind. It is only after generations of stars have lived and died and salted the gas that you can finally build a world with a surface, a world with a place to stand.
And our sun, our own sun, is which generation in all of that? Early in the line, one of the very first cooks, or late to the table, living off everyone else's leftovers? I feel like the answer matters a great deal for where I fit into this story, so don't spare me.
A latecomer. Our sun and all its planets condensed out of gas that had already been enriched by countless earlier stars. Stars that had lived and died long before the sun was so much as a cold, dark cloud. The earth beneath your feet, the iron in its core, the oxygen locked in its rocks, the carbon in every living thing crawling over it, every bit of that was cooked inside stars that were dead and gone before the sun ever caught its first spark.
So when I said, right at the start, a star that died before the sun was even a cloud, and I honestly thought I was just being poetic about it.
You were being precise, and you didn't even know it. That was never a flourish. That is the plain, literal, checkable history of the atoms in the ground you walk on, the iron in the Earth's core, the oxygen locked in the stone, all of it older than the sun, all of it made somewhere else and delivered here. The ground isn't the beginning of the story. It's a very late chapter.
All right, I have to check one thing because you keep saying, look at a star as though it just tells you all this outright. How does anyone actually know what a star is made of? Nobody's flown out with a bucket and scooped a sample off one.
Ah, and this is my favorite turn in the whole night, because it's an old friend of ours walking back in. Cast your mind right back to the very beginning of this series, the first thing we ever learned. The night sky is a what?
A time machine. Looking out is looking back. The light takes time to cross all that distance to reach us, so the farther out we look, the deeper into the past we're actually seeing. It's the first thing you ever taught me, and I've never once shaken it. But I don't yet see what an old idea about distance has to do with reading the guts of a star.
A time machine. And starlight carries far more than a picture. It carries a fingerprint. The light that pours off a star is stamped in a way we've learned to read clean off it, with exactly which elements are burning in it. Read the light, and you read the recipe of the star. We never once leave the room, and we can tell you what a star is made of from clear across the galaxy.
So you read the ingredients straight off the light. The star can't help telling on itself just by shining at us. That alone is lovely. But you said time machine, and you never drop a phrase like that by accident. So because looking out is also looking back.
Because it's also a time machine, you can read the ingredients of stars at every age of the universe at once. And when we do, here's the triumph: the very oldest, most ancient stars, the ones whose light set out in the deep past, turn out to be nearly pure hydrogen and helium, barely a trace of anything heavier in them. And the younger stars, the latecomers like our sun, are rich and thick with heavy elements.
Because the young ones were born into an already seasoned universe. They inherited all the cooking the old ones had done and died doing.
They inherited the cooking. So the starlight doesn't merely confirm the story after the fact. It lets you watch the enrichment actually unfolding right across cosmic time. The universe grows steadily richer in heavy elements as it ages, generation after generation of stars, and it's written out plainly in the colors of the sky for anyone patient enough to sit and read it.
All right, that one genuinely moves me. The sky isn't only a time machine, it's a time machine that shows you the universe, slowly getting more and more able to make things like us, the longer it's left running.
The longer it's left running, which carries us, at last, all the way back around to your stone in the shoe. Are you ready to take it out and have a proper look at it now?
I've been ready for the better part of an hour, so say it plainly. Am I made of stardust or not?
You are made of stardust. Truly, and not as a turn of phrase. The calcium holding your bones up, cooked in a star. The oxygen in every breath you draw, cooked in a star. The carbon that all of you is framed and built from, cooked in a star. The salt in your tears and your blood, the iron that makes that blood red and started this whole conversation off, all of it forged in stellar hearts and stellar deaths, ages before the Earth was here to catch it.
So the sentence was true after all. The stone in my shoe was a diamond the whole time. Every heavy atom in me was cooked in a star, and hurled across the dark to end up, of all the improbable places, here, wrapped up into a person who can sit and ask about it. I came down tonight ready to catch you in a beautiful exaggeration. Instead, you've gone and made it worse. It isn't exaggerated, it's just true.
Every heavy atom. And now, because I swore to you I'd never let you swallow a thing just because it was lovely, I owe you the one careful correction. And it happens to be a beautiful thing in its own right.
Go on then, where's the asterisk? I trust the beautiful things a lot more once you've shown me their asterisk.
Not every atom in you came from a star. There is one exception, and it happens to be the most common thing in your entire body by a mile. The hydrogen. The hydrogen in you, and remember, you're mostly water, and water is mostly hydrogen. That was cooked in no star at all. That one runs all the way back.
All the way back to the first 3 minutes, the Big Bang, the furnace that only ever made the light stuff and then slammed shut.
All the way back to the fireball. The hydrogen in the water that makes up most of you is very nearly as old as time itself. Primordial, straight out of the newborn universe, older than the first star that ever shone. So you're not made of one single thing, out of one single age. You are a stitching together of two utterly different epochs.
2 epochs. Say it properly for me, slowly. I want to carry this one out exactly right, word for word, because I can already tell it's the sentence I'm going to end up repeating to people. Which part of me is the old part, and which part is the star part? Lay it out so I can't get the two of them muddled.
The hydrogen in you is a relic of the Big Bang itself, from the very first minutes of all existence. And nearly everything heavier, the carbon, the oxygen, the iron, the calcium, that trace of gold, was forged long afterward, inside stars, and scattered out by their deaths. You are part primordial fireball and part stardust, sewn together into one walking, talking person.
Part fireball, part stardust. I think that might be the single truest thing anyone has ever told me about myself. And I only came down here tonight to pick a fight with you.
You came down to pick a fight, and you're leaving as a walking chapter of the universe's own history. That's a fine night's work, I'd say. But there's one last turn in it, and it's the one that puts a proper chill down my spine every time I let myself feel it.
You've got a chill held in reserve. Of course you do. You've been sitting on it this whole time, waiting for me to be softened up enough to feel it properly. All right, I'm softened. I'm about as full of wonder as I get. Deploy the chill.
Think about what has actually happened here, start to finish. The universe took the light elements from its own birth and cooked them inside stars and scattered them on the stars' deaths and gathered up the ashes into worlds. And on at least one of those worlds, the ashes arranged themselves into something that could look back up at the sky and slowly work all of this out.
The stardust figured out that it was stardust.
The stardust figured out that it was stardust. You are the universe's own way of looking back at itself and asking where it came from. The atoms in your eyes, cooked in stars that died before the sun was lit, are how the cosmos gets to gaze up at the very kind of star that made them. That's not poetry I'm draping over it. That, as plainly and flatly as I know how to say it, is what you are.
I need to just sit inside that one for a moment because, no, I don't think I've got a joke for it. And you know I always have a joke for it. The universe, looking back at itself, through us. Through eyes it built out of its own ashes, in stars, ages before there was anyone here to do the looking. I've got nothing. I'm just going to let it sit there.
You don't need a thing. Some ideas you just let stand there in the quiet. And I'll tell you, we're going to come right back to that thought, at the very end of this whole long journey we're on. It's a door well worth leaving open behind us.
Then leave it wide open. But you always do this to me. You get me all misty and full of wonder, and then, right on cue, you reach for your coat. Which means there's a next thing. There is always a next thing with you. So what is it you still haven't told me?
There's always a next thing. So here it is. Everything we've talked about tonight. The stars, the galaxies, the great web, the enriched gas, you yourself. Every scrap of it is sitting inside a universe that's expanding, stretching, growing bigger. We've known that much since almost the first night of this whole series.
Right, everything rushing apart from everything else, space itself stretching, the whole thing swelling out. We've had that since almost the first night. Every galaxy fleeing every other one, the farther ones fleeing faster. It's about the most settled fact in this entire series. So what could possibly be left to surprise me about a universe that just gets bigger?
And here is what everyone assumed about that for the better part of a century, and it felt about as safe as any assumption could ever feel. The universe is packed full of matter, stars, galaxies, all that hard-won stardust. And matter has gravity, and gravity pulls, so the expansion simply had to be slowing down. Every galaxy quietly tugging back on every other, gently, forever putting the brakes on the whole affair.
And that does feel obvious laid out like that. You throw a ball up in the air, gravity slows it on the way. The universe throws itself outward. Its own gravity ought to be dragging on it the whole time. The only real question left is how hard, and how soon it wins.
That was the only question anyone thought was even left to ask. How fast is the great expansion slowing? Will gravity win in the end and haul it all back in, or just barely lose and let it coast on forever? A sensible, tidy, respectable question. So they went out and measured it, found a way to clock the expansion clear across the universe and settle the whole matter once and for all.
And I can hear it in your voice already. That careful, delighted setup you use right before the floor gives out from under me. So let me just say it for you and save you the pleasure. It wasn't slowing down at all, was it? You went and measured the brakes and found there weren't any.
It was not slowing down. They looked, carefully, and then again to be sure, and they found that the expansion had, billions of years ago, quietly done the one single thing that nothing in the whole sky ought to be able to do. It had hit the gas. It's speeding up.
Speeding up, the entire universe, accelerating, with nothing anywhere pushing on it? No, that breaks the ball in the air picture completely. You don't throw a ball upward and watch it climb away faster and faster.
You don't. And that is precisely where I'm going to leave you standing tonight. Right in the wreckage of the most obvious idea in all of cosmology, holding an accelerating universe that nobody asked for and nobody can find a hand to push. So take your Stardust home, get some sleep, and come back down. Because next time, you and I go hunting for the hand on that accelerator, and what we turn up is, I promise you, the strangest thing in this entire story.
A universe that ought to be slowing, speeding up instead, with nothing behind it. All right, I'll carry the wonder back up the stairs with me, and I'll bring my suspicion right along beside it. Because a thing that accelerates with no hand on it sounds exactly like the sort of trouble you've been saving up for the end. Made of stardust, standing in a runaway universe. I'll be down early. Good night.